Welcome to the NGINX Armed and Ready panel. We have some distinguished panelists here, so let me go ahead. I'm Lakshmi Mandyam, and I run ARM's server strategy. With us we have David Harmon, who is a Strategic Alliance Manager for AMD's Server Business Unit, and he's responsible for providing AMD technical and marketing leadership for the enablement of x86 and ARM software ecosystems. During David's 20 years of experience in enterprise-class computing, he has held leadership positions in both engineering and solution architects roles. Next, we have Kumar Shankaran, Associate Vice President of Software and Platform Engineering. He's responsible for software architecture development and platform engineering for the XGene and XWE family of products from Applied Micro. He also handles the software ecosystem development and promotion within the ARM community. He's been a member of Linaro Enterprise Group, and he has a Bachelor of Engineering degree in Electronics Engineering and a Master of Science in Computer Science and an MBA degree in Marketing Finance. That's 2 more degrees than me, but anyway. We also have Shay Gallon, who's the Principal Engineer at Cavium. Prior to Cavium, Shay was at Embassy's Director of Software Engineering and leader of the Embassy Technology Center, responsible for the creation of many industry standards. He's had several roles in the microprocessor industry, including performance analyst at PMC Sierra, where Shay has influenced the design of new processors and a variety of other places. Shay holds a CS bachelor's degree from Technion Israel Institute of Technology. So thank you for joining us this morning. So what we'd like to do for the format of this panel is each of us will give you a bit of background about our companies and what we're working on. And then we will have some questions, and we'll throw it open to the audience. So with that. So many of you have actually come up to us in the course of this event and asked us, ARM, what are you guys doing here? What's the connection? Well, actually, the face of computing has kind of been changing slowly but steadily, and has definitely accelerated over the past 5 to 7 years. ARM is well known for our presence in the mobile and consumer space, and we're starting to see that our products are actually delivering performance levels and are able to address a broad set of market applications in the infrastructure space as well, in networking and server applications. So the business model for ARM is we are actually the global leader of semiconductor IP development. So our partners that you see here today actually license our technology and develop chips and systems that go out into the marketplace. And some things that you may not know about ARM, there are over 1,300 licenses, and every year we license 100 additional customers. There are more than 400 companies that have licensed our technology. And last year alone, we shipped 12 billion with a B processors, and over the life of the company, which is now around 25 years, we've shipped around 60 billion, again with a B, processors. So over the course of the time, the ARM product has actually evolved. We started out with 32-bit microprocessors, and we now have a large number of 64-bit microprocessors that are addressing applications as diverse as mobile phones all the way to servers, and hence our push to come and talk to you today. So the ARM server ecosystem has actually been evolving for the past 4 or 5 years, and more recently there's been a focus on 64-bit platforms coming to the market to address the kinds of applications and performance points that are needed in enterprise applications. And so this is an example of some of the ecosystem partners that we have working on ARM. So I kind of built this diagram as a stack because you need many components to make a very vibrant ecosystem. So from a semiconductor perspective, we have partners partners like AMD, Applied Micro, and Cavium that are actually starting to ship to a broader set of customers. We also have partners like Broadcom, Marvell, Qualcomm's announced. So there's a rich ecosystem of SoC partners who are going to be bringing hardware solutions to the market. We have also made a lot of progress in terms of having a number of OEMs that are starting to offer platforms. And actually, if you walk over to our booth when you have time later on today, you'll see that we have platforms from all of the partners sitting on stage here. And some of the well-recognized names in the industries are starting to offer platforms as well. But most of you here, probably being software developers, care about the software ecosystem. So one of the key things that we've always focused on is open source. And so we have, from the get-go, said that the ARM server applications would be well suited for open source applications in web, storage, networking. And actually, one of the reasons that we're here today is we see a great benefit of the NGINX ecosystem and the ARM ecosystem working together to deliver real value to end customers. And so we have vibrant support for Linux from Ubuntu, SUSE, and of course Red Hat as well as some of the open source communities, should you choose to take stuff directly from them. We also have seen a lot of the applications that we list here running well on ARM based servers and delivering significant value, whether it be in performance per watt, per dollar, per cubic foot, all important metrics for end users. And we have a number of end users that are going to be deploying based on ARM servers. So with that, I'm going to turn it over to David, who's going to give us a bit of a background on what AMD is doing with ARM.
All right, welcome. Thank you for joining us today. As you can see, AMD has a rich history in server with the x86 market, first to market with the 64-bit on that platform. We're doing the same thing with AMD Opteron in 64-bit ARM. We've got the A1100 series, which is our first ARM offering. AMD is really focused on the enterprise aspect of things associated with ARM. It's all about choice in the sense of different architectures, different opportunities require different solutions, and so this offering here is really designed around lower total cost of ownership, really open ecosystem, industry standards with an experienced server, server vendor. We pride ourselves on really being open source friendly, and you can, I spent this week here at Linaro Connect and really doing a significant amount of work associated with enabling this platform for the open source community and as Lakshmi mentioned, the different OS vendors that we have out there. There's a good handful of high quality OSs that are currently available and running on this platform as of today. So the current offering that we've got, which is available as of today, is the AMD 1100 Opteron on a soft iron platform. This is a development platform, yet it's enterprise class. I mean, it's a development as an intro to really understand what you can do with ARM in the data center. AMD's design was really focused around making a transition as seamless as possible from an existing environment that everybody knows and loves in the x86 environment, but offering a choice with an ARM architecture. So this is it's a 1U rack system, quite impressive for what it's able to do with the 4 to 8 core different options, 2 10 gigabit Ethernet ports, SATA 3 ports, supports PCIe Gen 3 with up to 16 gig of memory that is installed. And like I said, these are available at this point in time. So if there's an interest in ARM and you're kind of kicking the tires, this is an awesome platform to kind of really check out and test on. I recommend you take a look. Thank you.
Thanks, David. So moving to the next person in line here. So my name is Kumar and I'm from Applied Micro. And Applied Micro specializes in the XGene family of ARM 64-bit processors. And we have been in the market for several years. working with ARM in promoting ARM servers for the data center market. And we think there's a huge market here in the next few years, and we are out there to capture some of it. So what we've been doing here is making multi-core ARM 64-bit CPUs, what we call server on chip. We like to call it server on chip rather than system on chip. The reason is majority of the features that servers need today in terms of interfaces, PCIe, SATA, networking, and are all embedded within one single die. And that's the same offering from AMD or Cavium or all my colleagues who are sitting here. We are all trying to do the same thing, which is build a server on chip. So what we feature with XGene is multi-core 64-bit CPUs, depending on the product that you're looking at. You have multiple SKUs, and each of them is a multi-core CPU with typically a 3-level hierarchy of caches. So we have L1, L2, L3 caches, very similar to Intel or anybody else in the data center market segment. Out-of-order execution, hardware virtualization, and coherent networks for SMP or Linux SMP is very critical in the data center, which is supported in the architecture. So I'll touch on the hardware side briefly, and then for all the software guys, we'll dive into why NGINX is important here and what we're doing to improve the NGINX performance in ARM servers, which is very important for us. On the connectivity side, all these CPUs feature multiple PCIe or SATA, USB 3.0 mainly for booting, and integrated 1 GBE or 10 GBE. Going forward, it'll expand to 40 GBE to 100 GBE. And UARTs, low-speed peripherals, I2C, SPI, MDIO, GPIO, these are pretty standard offerings in all products these days. On the memory subsystem, DDR3, DDR4 channels, a very important requirement. On the boot power management, so ARM has architected this body called SBBR, and that enforces some compliance amongst all the vendors that are literally sitting here on this table and all the other ARM vendors out there. So we comply with those standards in terms of bootloaders like UEFI and ACPI for power management and even booting. Now moving to other production servers that are available today, David talked about some of the systems from AMD. These are some other systems that are available in production today. So the first board that you see on the left is the Applied Micro Mustang or XC1 platform, available widely. It features ARM 64-bit CPUs in a multi-core environment. The HP Moonshot M400 platform in the middle is a HP product in production today. So you can actually order this from their website. And the last one is the Gigabyte MP30 platform. It's a motherboard based on an ARM 64-bit architecture from Applied Micro XGene, very similar to an Intel motherboard that you see out there. You can buy from any vendor. Moving to the software ecosystem, as Lakshmi mentioned, so some of the OS vendors that support NGINX today in production are Fedora 22, RHELSA, which is Red Hat Enterprise Linux for ARM servers. So the one version that is out there today is 7.1. CentOS 7.1, which is based on RHELSA 7.1. And then lastly, Ubuntu 14.04 LTS, which has been out there for over a year. So all these support NGINX in production and commercially supported today. So very good progress for the NGINX community in getting these into these production distros. So moving on, I just wanted to touch on some important...
sorry.
Oh, that's okay.
The format got messed up.
Okay, so some important performance that we have when we run NGINX on XGene. So there are two charts here. It might be difficult to read this chart, but I'll maybe walk you through this. The red line is the NGINX performance, and the blue line is the Apache performance. So we compared NGINX performance with Apache running on XGene in pretty much an identical configuration while running a web server benchmark called Work. So we ran the benchmark, measured the performance with varying data sizes. So what you see on the x-axis is the data size in bytes or kilobytes, going from 1K to 64K, which is typical when you do a web server. And then on the left chart, on the y-axis is requests per second. So on the left chart, the higher the better. So if you see a higher number, the better it is. And on the right chart is TB90 latency, which is the latency for 90% of the requests to be serviced by the web server within a particular period of time. So on the y-axis is the time in milliseconds, the latency, and the x-axis is again the data size. So you can kind of see, if you look at these charts one by one, the NGINX performs significantly better. Yeah, sure. I'm sorry, what? The blue line is Apache. So it's an Apache web server. So the blue line is the Apache web server. The red line, apologize for the formatting here. So the red line is Nginx, the blue line is Apache. And so the Apache web server is 2.4.7, as you see there, and the Nginx version is 1.4.6. So, yeah.
We don't have.
Yeah, we don't have those data here, but it's a very. You mean you're talking about ARM Nginx on ARM versus any other architecture, right? True. Yeah, yeah. The question. Let me repeat the question. The question here is there any performance data comparing Nginx on ARM versus Nginx on any other architecture? The answer is yes. We do have a lot of data that we are not showing here today. So what we are trying to address here today is to just show the maturity of Nginx on ARM versus Apache on ARM. So that's what we're trying to show here. Okay. So anyway, so to conclude, the whole idea here is that Nginx provides about 2x greater performance at half the latency. So with that, yeah, I'll hand it over to Shayon from Cavium.
Hello, my name is Chai. I work for Cavium, and specifically I work on a product called ThunderX. This is a product by Cavium, a processor, an ARM processor, with up to 48 cores. So this is something we believe in, that if you take a processor and target it at specific workloads, you can do a lot better than a processor which is aimed at any possible workload. In particular, the ThunderX family is aimed at data center type workloads. Nginx would be a perfect example, where it's a web server or a load balancer. And the question is, what do you need in order to make something like that work and work well? Well, obviously you need a processor to do the processing, but as was pointed out, you also need maybe a network interface, PCIe. You'd like all that to be in one package. Something that John has brought up in the previous talk, if any of you have been here, is that the secure web is really important. So it could be really useful if that processor also had the capability to offload the security processing part, whether it's for establishing connections or for compression, or for encryption and decryption. So the ThunderX family gives you the ability to do all that in one processor, offload whatever is needed, and you don't need another chipset in addition to that. Another thing that may be interesting is that we've divided the ThunderX family into different SKUs depending on what kind of workloads you believe you'll have to do. So, for example, the ThunderX ST SKU looks at storage, and for storage you might need more channels to work with more disks. The ThunderX SC SKU looks at the secure web, where you want to be able to establish lots of secure connections. So depending on what you need, we have devices that are capable of answering that need. In particular, again, talking about Nginx and the secure web, you want to know that you have the capability to scale up in performance. So the ThunderX can do from 4 cores up to 48 cores in one socket, and we have dual socket systems as well available. All the encryption is integrated, and we have if you look at this slide, it has Inventec, Mytek, Gigabyte, Asus, Penguin computing system, Wiwin. All of those vendors are building systems, and you can go and get a ThunderX system that you can put in a rack and immediately work with it. You can install Ubuntu, go sudo apt-get install Nginx, and you're up and running with Nginx. If you have Nginx Plus, obviously you get all the features that come with that. How do you use the secure capabilities in this processor? if you're using OpenSSL, all you need to do is in the Nginx config file, say SSL engine, Cavium, bang, you're connected to the Cavium acceleration. And that's basically it. The idea is to have a single solution targeting specific workload, in this case Nginx, and make it easy to work with, install, manage, and it's all built on ARM.
So with that, I thought we would perhaps have some questions to start off the conversation. Of course, all of you are welcome to ask questions as well. So one of the things that all of these three companies bring is a vast experience in different spheres, whether it be in networking or servers or other areas. And this is the kind of innovation that's being coupled with the server solution to bring some differentiating solutions. So I guess I'll throw it to all three of you, maybe starting with Kumar. What are some of the innovative solutions that people can do with some of the SOC features that you guys have integrated into some of your applications?
Yeah, so in terms of integration for data centers, we feel it's very critical for any SOC vendor to provide the majority of the interfaces that are primarily used, right? So those would be things like integrated 10GBE, integrated PCIe, or lots of PCIe, and also integrated SATA, right? So with integrated features, let me just take the example of 10GBE, for instance. So you can have a variety of applications like acceleration of NFV, network functional virtualization. As Shay mentioned, secure SSL is another application that can be accelerated. There's ODP in the community that is getting very prevalent for ARM architecture for accelerating both crypto as well as networking performance. So yeah, variety of applications can be accelerated by using these built-in accelerators that are there in these SOCs.
Okay, great. Anyone else want to add to that?
I'd have to say just the overall, standards and ecosystem enablement that AMD's done is really around the transition and usability of the platform. So the basic requirements, like Kumar mentioned, the Ethernet, it's there, PCIe's there. As the maturity of this platform continues to grow from the OS level up to the driver stack, up to the solution stack, just the seamless migration from different architecture choices depending upon the workload that you're looking to target at this platform.
You asked about innovation. I think something that the ARM ecosystem helps with is easing the innovation. So ThunderX has 48 cores, and they all run seamlessly and run Ubuntu, all the services, Nginx, and you can bring it up very easily. The ecosystem that's there for support of ARC64, I think was very key in enabling that innovation.
Yeah, it's quite interesting. One of our, I think everyone on the panel knows him, but one of our great technology colleagues, John Masters, has been known to say that ARM servers are boring. And some of the times the people at ARM are like, what do you mean they're boring? Well, they're boring because everything just works on it and it's easy to integrate and deploy. At least that's what we've heard from several end users. So for some of the developers that are here that are looking to start developing on ARM-based platforms, what are some of the avenues that they could pursue to make that happen? I guess we'll start with, since you're holding the mic, Shai.
Sure. Actually, it's a great question. We've recently announced a partnership with OVH, which is the biggest cloud provider in Europe. And you can go to the OVH, sign up for the ThunderX lab, and fire up a VM on a ThunderX with 2, 4, 8, 16 cores. Just choose your flavor, bring up a VM, and you can start playing with it. Very easy.
Okay.
I would say target whatever your solution is, and really, throw it at any one of us to, identify that, ultimate solution with ARM. As we progress with this ecosystem, we want to see what the end user is really going to do, and the cloud environment for spinning up VMs. We've done that with some of our NDA partners at this point in time, and as we release more hardware, we're looking to do that as well. But it's an awesome solution to be able to do that, and I highly recommend.
Sorry, David, just to add, I shouldn't be doing this, but I'm going to do it anyway. You guys just announced a developer platform, and we actually have that in the booth here, and people can pick up information on how to order those as well.
Yes, exactly.
And to add to what both the gentlemen here said, so we, Applied Micro, we have a partnership with Data Center. So that's a data center company based in the UK. So you can exactly do the same thing, lease out a cluster or lease out a VM. They run OpenStack on top of our XGene architecture. So you can lease out a VM, pretty much download Ubuntu on there, run Ubuntu or Relsa or CentOS on that VM, and then just do apt-get install and Nginx, and you're done. It's that simple. So we have made it that boring, which is the important part.
Any questions from the audience? Sure.
Cavium was for decades known as a MIPS shop. So what specific advantages are ARM versus MIPS? Why did Cavium switch, which I'm baffled about, by the way?
Okay, let me repeat the question for those who didn't hear. I think the question was, for quite some time, Cavium was using MIPS cores, and why did they move over to ARM?
So Cavium also continues to develop a MIPS-based, the Octeon family. We didn't switch, we just use whatever's the best for the particular target we're targeting at. The ARM ecosystem is very strong, and with MIPS being acquired by Imagination, I think the company felt that it was wise to diversify.
Any other questions? Okay. So how easy is it to deploy and manage ARM-based solutions in an existing environment?
Sure. There's a lot of cloud infrastructure on managing and deploying x86-based systems. And we found that the ARM ecosystem makes it really easy to do that on ARM. We've had to get in touch with a variety of companies like Nginx, like Ubuntu, the Canonical, or Red Hat Foundation. But once we made those connections, there was very little that was needed in order to enable exactly the same management stack as you use with your current solutions to work on the ThunderX platforms, which is ARM-based.
Yeah, just to kind of add to that, the ARM ecosystem actually created the server-based system architecture where it supports existing standards like UEFI and ACPI to enable that kind of standardization and ease of management. So.
On the AMD front, it's no different than an AMD x86 server. It's the specs might be a little bit different, obviously from the core count perspective, or overall features or an ISA instructions, but it's simply the same. I mean, it's just literally just racking it, IPMI functions, BIOS aspects of everything of how it's deployed and enabled. So it's just roll it in and kick the tires.
Yeah, just last thing was consistency is critical. So we try to make sure that the change that you have is kind of minimal or next to zero, right? So that's what we aim for. And all ARM servers, due to the standardization, as Lakshmi mentioned, of ACPI, UEFI, boot process, and all the architecture of management itself, we have made it pretty much identical between the traditional infrastructure of x86 versus ARM servers. And it applies for all the ARM vendors.
And there are actually a few partners that have already deployed where they've deployed ARM servers within their existing infrastructure, and they're able to manage, migrate, do whatever they need to do in that environment. Sorry, David.
No worries. One other comment too. John Masters, obviously from Red Hat, has been instrumental in the SBSA, pushing the standards aspect, and he's right. I mean, trying to make keeping server boring and that it rolls in, its usability is standard, everything as defined just works. And the boring aspect of what we're doing from an ecosystem perspective behind the covers, behind all the work that's being done from Linaro, from the partners up here, it's exciting to see. I mean, so as all the excitement behind the scenes, it is creating some boring infrastructure that just works.
All right. Shai, did you want to say?
Yeah, just one thing I wanted to add was, so at the Red Hat Summit last year, John Masters, he had done a side-by-side real installation of RHEL on an AMD x86 cluster with an Applied Micro XGene cluster side-by-side. There were 12 nodes. And the installation of RHEL was pretty much identical. The kickstart process, the installation, the installer, the Pixie server was identical between the two servers. So there was no difference at all. And even the boot time was identical.
And actually, you bring up a good point, because I think at the OpenStack Summit in May, I believe, Mark Shuttleworth from Canonical demonstrated orchestration using OpenStack for both x86 and ARM together. And in fact, from an Ubuntu perspective, they certainly have support for Maz and Juju and other orchestration tools that allow you to easily deploy and manage these servers.
That's correct, yeah. So at the OCP, Mark Shuttleworth is the CEO of Canonical, so company that owns Ubuntu. So exactly what Lakshmi said, he demonstrated the identical functionality of OpenStack on Ubuntu on ARM versus x86.
So kind of for any questions before I ask the next one? Okay, so one of the interesting trends that we're seeing and some of the disruption we're seeing is around converged infrastructure, right? Where we're seeing applications in the telco space, like SDN and NFV come to bear, and also we're seeing, software-defined whatever, whether it's server, storage, or networking. And our belief is that the ARM ecosystem, because of our heritage in those spaces and some of the unique functionality that the variety of partners can bring, can offer some significant benefits over just taking a vanilla approach to solving all problems. And so with that, I'm going to throw it over to Shai. So can you talk a little bit about how some of those aspects in terms of what the ARM partnership can bring can deliver value to end users?
Okay, so here maybe I'll talk about a little bit of a challenge. When we started looking at these services, we found that the industry has spent a lot of time optimizing these on x86 servers. And while you work on the ARM ecosystem, everything just works, still, it's not maybe as optimal as it could be. A lot of these services have, for example, x86 assembly code in them, and not the same for ARM. So we actually had to go in and say, if you want to do this and do this well, you also have to have a little bit of code that's ARM specific or ThunderX specific, and we're working with the partners to upstream those so it's part of your normal. Let's say you have a cluster and you have an Ansible playbook to provision that cluster with everything that's needed. How to make sure that you get optimal performance out of that cluster.
I guess I was also trying to get to some of the innovative things like the heterogeneous processing elements that you're bringing into play, which can actually deliver significant performance when you look at end applications.
So I sort of touched on that before. What we've done is make sure that the only thing you need to do is, for example, if you look at offloading compression or offloading encryption or session establishment, the only thing you need to do in your configuration file, just redirect to the correct device driver. So you go SSL engine, Cavium on an Nginx configuration, you immediately get to that. You turn compression on, gzip on, you immediately get to the offload for Cavium. It's not you don't do anything, you don't have to do anything special to take advantage of these offload devices.
Yeah, I mean, I hate to reiterate the point, but it's as the converged, moving from transitioning from either an x86 environment or to the ARM environment, it's simply just working there, and so it's mildly, it's mildly difficult, and as you transition over from a converged environment or into a converged environment, it works. It just simply works.
Yeah, what I wanted to say is I think ARM here has played a very critical role in promotion of the ecosystem itself, ARM as a company and the overall open source ecosystem. And Linaro, right? So these two companies have joined together in defining standards that would get the best optimal performance from ARM servers, right? As Shai mentioned, things work, but you want it to work in a manner that's optimized for that particular target application, right? So things that I mentioned before, like ODP, for instance, that's an organization or a standard that's being promoted by both ARM and Linaro. And DPDK, for people who have been using DPDK on the x86, they're very used to DPDK, right? So the resistance to change is high. So we are again working with Linaro and ARM to have DPDK, a version of DPDK for ARM that'll look exactly identical to the x86. Yeah. So I think the ARM and the Linaro have played a very important role in the ecosystem maturity.
So I guess we have time for one last question because I think we are down to like 3 or 5 minutes. So with that, I'll say, what specifically are you seeing as being an advantage of working with NGINX? What are some of the benefits that you guys are working on with NGINX to make it, really offer a compelling solution to end users? I'll start with Kumar.
Okay. From the NGINX perspective for Applied Micro, it's been very important to get NGINX working. The primary reason is NGINX, the performance of NGINX, right? The speed and the latency of NGINX is critical in majority of the applications we target our servers for, right? So latency is critical. So in financial applications where ARM servers are being positioned, latency is very critical. And so what we envision NGINX is, at this point in time, we think the front-end servers, application servers, where very high performance and latency is a critical thing, or speed is a critical factor, NGINX is very important. So we have, that's the reason you saw in my slides, that we have done a lot of work with NGINX and Apache and comparing them sort of side by side in a variety of market segments we go after. So yeah, NGINX is a pretty important factor for us for data center penetration.
Yeah, web service for AMD for this specific, for the AMD 1100 Opteron is a key target for sure, and NGINX running on that at high optimization is critical for us. We've just with our recent announcement with our soft iron release with that platform, we've just started working with NGINX and finding that we can do a lot of different optimizations and looking to provide some potential benchmarks to the community based upon what we find there.
So NGINX is relatively thin as a code base, which makes it easy for us to take a look at what's there and make sure it's optimal for our platform. Or if not, it's easy to work with NGINX engineers and upstream whatever is needed to make it optimal. Does that?
I think so. I think just from my perspective, from the ARM perspective, we've been working with NGINX. It's been a great relationship for us, and we see actually a lot of end users who are interested in deploying on NGINX with ARM. And again, the value proposition that the partners bring in terms of specialized functionality, in terms of lower power, will actually enable end users to experience better performance per watt, per dollar in terms of applications like these web tier of applications that NGINX specializes in. So if you have any questions, feel free to come up and chat with us. We'd be more than happy to do that over lunch at the food truck. But thank you very much for attending and delaying your lunch to listen to our speech. So thanks a lot.